To make PCR work quickly, a machine called a thermocycler is used to change the temperatures of the tubes that the DNA is in. This makes each step go by faster so you don't have to transfer the tubes to different water baths, and it maintains the accuracy of the temperatures. The first step of PCR is called denaturation. This is where the strands of DNA are heated up to 95 degrees Celsius for 30 seconds. This breaks the hydrogen bonds between the strands. As shown here, if you were to heat this up to 95 degrees Celsius, it would break the individual hydrogen bonds that I have between each nucleotide. So here, the hydrogen bonds have broken and the DNA segment is beginning to split. The result of this step is 2 single-stranded DNA segments. The second step in PCR is the annealing step. This is where the 2 single strands of DNA are heated up to 50 degrees Celsius so the PCR primers can bind. You need 2 primers because the Taq polymerase in the next step only works in the 3' to 5' direction. They bind in a specific spot because PCR amplifies just a small part of DNA, not the entire thing. The next step in PCR is the elongation step, or the extension step. This is where the Taq polymerase binds to the PCR primers and begins to create more segments of DNA. More free nucleotides are added onto the Taq polymerase, and it helps create more hydrogen bonds between each individual nucleotide. This creates a longer strand of DNA. Now that we have 2 DNA strands instead of the one we started with, we can do this all over again to make 4 DNA strands. PCR is repeated many, many times, and each time is doubled, and the results are shown here. These are the strands I just created from the third step. If they go through each step again, you will end up with 4 strands of DNA, as shown here. This is the denaturation step where the hydrogen bonds are broken. This is where the PCR primers bind to the single strands of DNA in the 3' to 5' ends. Then the Taq polymerase binds to each DNA segment, so we have 1 single strand, 2 single strands, 3 single strands, 4 single strands. So the Taq polymerase binds to each strand and adds more nucleotides on and creates more hydrogen bonds from the 3' to 5' direction. After this is finished, you end up with 4 double-stranded DNA segments. If you were to do this again, you would get 8 strands of DNA. And if you were to do it a 4th time, you would get 16 strands of DNA. This is important because it helps amplify the DNA so much that you'd be able to test it using an additional molecular technique.